Alright, hello everyone. Welcome to the presentation on nonviolent communication. But don't worry, I'm not from Human Resources Department and I'm not going to tell you how you should or how you shouldn't talk to your colleagues. This presentation will focus on one aspect of testing microservices, which is contract testing. At the end of this presentation, you will know what is contract testing, what kind of problem it solves, what are other solutions to those problems, and what are two common approaches to contract testing. I will also present a short demo using one of well-known contract testing frameworks. My name is Rafał Maciak, and I've been a software engineer for 12 years, currently working at Software Mill, and today also representing Java user group in Łódź. I'm coding in Java at Kotlin, been working with big monoliths and even bigger microservices, like three-letter acronyms like TDD or DDD. And also what I like about software engineering is testing. And this is actually the reason behind today's presentation. Okay, but let's start with defining the problem that I want to solve with you today. So, it's 2023 already. Even though as an industry, we've already grown to the point that well-crafted modular monolith is also cool, also sexy, when I find the friends, whether at the conferences like today or at local meetups, I sometimes hear that proud proclamation, I work with microservices. Sometimes I even have the impression that people who work with monoliths are ashamed of it. However, I think that they shouldn't, because the monoliths have some advantages over the microservices in some specific contexts. But before we will delve into those advantages, let's have a quick recap how monolith works. So, monolith is a single deployment unit which encapsulates the business modules. It operates within the scope of single system process, so consequently the module shares both CPU and memory. The modules communicate using local function calls. For example, in Java, there is a public method which may be executed from another module. An important advantage of this is that the compiler ensures the communication correctness. So, for example, if you change the contract, let's say that we add the parameter to method signature, the compiler will ensure that the modules communicate correctly. The code won't be compiled, won't be tested, and what is most important, will not be able to deploy this to production. So in other words, compiler ensures the communication correctness between our modules. And when it comes to microservices, a challenge arises. And this is how to ensure that microservices communicate correctly. So let's check what to communicate correctly means in this context. So if one service sends a request to another one, this request should be received, understood, and processed by this receiving microservice. Additionally, as a result of this processing, there should be a response generated, which is also understood to the receiving microservice. And also, there is the network between the microservices. Let's see a specific example. Imagine we are working in the e-commerce business, and we are developing the feature of order creation that should be automatically paid. Microservice architecture, so we have two microservices. Order service, which is responsible for order creation, and payment service, which handles payment processing. The second one will expose the REST API, which allows to initiate the payment. As we can see, this is a HTTP put with path/payment/UUID, and in the body there are 4 fields: account ID, quota, payment type, and due date. In a happy path scenario, this API should return 200 OK and 2 fields in the body. So, returning back to our challenge, how to ensure that microservices communicate correctly. Let's delve into some technical aspects of this. What it really means technically. So, it means for me that if we take these microservices and we deploy them to production, they should cooperate correctly, and as a result of this cooperation, there should be some business functionality provided. Speaking more technically, in case of the REST API, it means that this is a correct request. So the request should contain correct method, correct path. There should be expected fields, headers, and fields in the body. On the other side, the response should be generated, and this response should contain correct status code, also headers and fields in the body. However, if this communication would be implemented using message or driven approach, this communication correctness would mean that there was the correct message sent to correct channel. For example, the message with appropriate header and body was sent to specific Kafka topic. On the other side, the message should be consumed by all the consumers and processed correctly. Okay, so we successfully deployed our microservices to production, and to our surprise, they are functioning well. Customers are satisfied with our product, and the business is thriving because it's making money. Great success, right? However, as you are likely aware, it won't take forever. Especially in today's fast-paced business environment, the changes are inevitable. Sooner or later, we'll have to modify that code. And this is the point when the second challenge arises. So, how to ensure the stability of the communication? So let's see what it means. It means that if we change the code, it is still able to communicate. For example, imagine the situation that one day product owner comes to a desk and asks for a new feature in payment service, which required changing the API used by the order creation process. For example, we add the required field in the request. What we want to achieve is both old feature with order creation and payment initiation process to work correctly, as well as the new one. So, of course, I'm talking about ensuring backward compatibility. So, now we know the problem, we know the challenges. Let's jump into the solution space and check how we can solve them. There couldn't be a presentation about the testing without the testing pyramid. This is quite a basic testing pyramid with unit tests at the bottom and end-to-end test at the top. Let's check whether any of those layers help us with our challenges. So, I'm immediately excluding unit tests. Why? Because unit tests are the tests which validate the specific unit of the code. Whether it is method, class, module, it doesn't really matter. What is crucial here is that those tests, they do not validate the network communication. And since we are dealing with microservices, which are using network communication, this approach is not applicable. So let's check integration tests then. So integration tests are the tests which confirm whether the independently implemented parts of the system cooperate correctly, successfully, and as the result of this cooperation, there is some business functionality provided. And integration tests are cool because they allow us to test in isolation. I can test order service, my colleague tests payment service. If the tests pass, and of course they are implemented correctly, we may be pretty sure that this feature works fine. They are also a very powerful tool for testing the functionality of the system. I highlight the functionality here for a reason, because I often find that developers overuse integration testing for validating the communication. And I think so, this is not the best approach. I will clarify why I think so. But before we'll delve into that, let's check the difference between the integration test which validate the functionality and the one which validate the communication aspects. So the first one is the test which validates the functionality. So in such an integration test, we may call the API and check whether all the business functionality was met, whether all the business requirements were met. For example, we can check that payment was created in any database, maybe some required events were published, like payment initiated, or collaborators were called. In that case, it could be payment gateway that was informed about this payment. So, as you can see, such a test, it focuses on the business aspects, on the functionality. And in the contrast to such a test, there is the one in which we also call the REST API. However, instead of focusing on the functionality, on the business value, we check the communication aspects. For example, we check whether the status is 200 in the response, whether there were expected headers returned, and fields in the body. And as I said, I think that integration tests should not be used for such kind of validation. And now I will provide you 4 reasons why I think so. So, the first one is that in order to correctly test the communication using integration test, there must be 2 sets of tests without any synchronization. So, on the client side, order service, how do we test it? So usually we use the API stub, which simulates the real API. Then we call whether the HTTP client level logic or domain logic, it doesn't matter. What is crucial here is that we call it against the stub, not the real API. On the other side, we have the payment service test. I already explained that we call the API and we check the communication aspects like status, headers, body, and others. However, as you can see, there's a thick line between those 2 entities. Those are usually separate projects, separate repositories, possibly separate teams are responsible for maintaining them. The teams may be even distributed across the world, one in Europe, another in America, let's say. So there is no any synchronization between those 2 entities. If any side of this communication changes the contract, another side is not automatically informed about it. Let's see an example. Imagine a new joiner of our team decided to change the status field to payment status just to keep the naming consistent. So he or she changed the code and pushed it to the branch. The test, let's say, of all the system were run. And how do you think? The test of order service, which is a client of this API, do they pass or not? Yes, they do, because order service was not automatically informed about this change. In the API stub, there is the still status field, which is, by the way, expected by the order service logic, so it works. On the other side, we have the test of payment service. And yes, probably, while implementing this change, they failed. However, if we change the logic, we change the test. So they also pass. So we have both sides green. We deploy this version to payment service to production, and what? We're in trouble, right? The feature doesn't work. Order service does not understand the response of payment service. The feature doesn't work. Customers are complaining, and the business is in panic mode. We need to fix it as soon as possible. And now you may say, man, but it doesn't work like that. If we are responsible for maintaining the REST API, which is public, we should find our customers and inform them about this change, which is not backward compatible. And yes, I agree with you, this should work like that. However, this is the second reason why I think that integration tests are not the best approach for testing the communication of the services, because they strongly rely on the human communication. First, at the integration phase of the system, we need to communicate a lot of. Whether this is verbal or written communication, it doesn't matter. What's crucial is that we need to agree on the contract between our services. Also, as I showed, all the breaking changes must be communicated. And as we know, human communication is unreliable by nature. So let's imagine this is the verbal communication between two non-natives. Someone said night, someone else could understood night, and this could lead to an office dispute. However, as I mentioned at the beginning, we aim for non-violent communication. And last but not least, using only integration tests, the team responsible for maintaining the API does not know how this API is really used on production. For example, a part of order service that could be actually potentially unlimited number of unknown clients. Let's say a refund service and credit service. Now you can say, okay, but there are the tools for that. For example, service mesh. If we have service mesh, we perfectly know who is calling our API. However, I think the service mesh is not very popular on the project. Who of you has service mesh on the project? Just 2 hands up. So yes, as you can see. Additionally, each of those services may use our API differently. For example, order service may expect only payment externality in the response, while credit service status field, refund service status field, and credit service, let's say 2 fields, payment externality and operator. Let's say that our API returns 4 fields, and here on this slide, we see perfectly that payment type is redundant. However, based on only integration test, we are not sure whether we can safely remove this field. And there are also solutions for that. For example, API versioning, right? We can create the new version of the API without this field, ask our customers to change this version. However, still, we cannot assure that the new version of the API that it works correctly between the client and the service which exposes this API. So those are the 3 reasons why I think that integration tests should not be used for validating the communication. But don't get me wrong. I'm not saying that integration tests are bad and that you shouldn't write them. Yes, you should. I also do. However, I'm implementing the integration test which focus on the functionality, not on the communication. So, testing pyramid. I'm also removing integration tests from this list. So let's check end-to-end tests then. So the end-to-end tests that are the tests which run on the real instances of their services and confirm that system as a whole works as expected. So usually they are implemented by deploying all the services or just a subset of services to the special environment called stage or test. But 2 services are in the testing configuration. Then we run the test scenarios against this environment. How do we do it? How do we do that? So usually by simulating the user's behavior. Whether this is the user clicking on the UI or calling the REST API, it doesn't matter. The crucial part here is that in the test assertion, we validate whether all the expectations regarding the functionality have been met. So for example, in our case, we could check that order was created, it is visible in the system, and it was paid. And end-to-end tests are cool in context of communication because they guarantee the communication correctness. How it is done? So if we execute the real business scenario against the environment with all our services, and we check whether all the expectations were met, we may be sure that under the hood, the services communicated correctly. Of course, we have more asterisks here, because those services are in the testing configuration. When we go to production, it may turn out that this configuration is incorrect, and for example, they won't be able to find each other in the service discovery. But this is kind of configuration on infrastructure issue that we cannot really test on the service level. However, as you probably know, end-to-end tests have some drawbacks. So we can test the services in isolation, like with integration tests. We need to deploy them to production, to the special environment. So we need the server for that. The server is a cost itself. And also we need a DevOps team who will maintain and create this infrastructure. So end-to-end tests are expensive. They are also slow and flaky. Remember, there is the network between the services. Network causes the delays, so the end-to-end tests are slow, or slower than the integration tests, in which we call against the stub. Flaky tests. My bad experience from some previous projects is that we had a big set of end-to-end tests which failed randomly. So with so-called false positives. So after a couple of weeks, we are not sure whether this is the real failure because we changed any code or just a false positive. So we haven't trusted them. Okay, so let's think. If we have a fire sensor at home, how do we test it? By putting a house on fire? I hope you don't do it. Usually there is a button, push to test, so we can just press it and check whether the sensor is working correctly. However, as you probably know, it doesn't guarantee that in the real fire situation, the sensor will work correctly. So, testing pyramid, end-to-end test, I also removing from the list of the solutions. So, what can we do? You're probably guessing that I will try to sell you the contract tests as the solution for these problems, and that's the true. You are guessing correctly. So, what is contract testing? Contract tests are the tests which confirm that the correctness of the communication between two services, but based on the contract. What is contract? I'll explain in a minute. Now let's see what are the advantages of this solution. So they actually mix the advantages of integration and end-to-end tests. First, we may test in isolation, like with integration tests. We don't need any infrastructure for that, so this is actually a cheap solution. But what is the most important, they ensure the communication correctness. They also mitigate the issues of integration and end-to-end test, what I will explain soon. Okay, so what is a contract? You may think of contract as a document which defines the communication aspects of our services using domain-specific language, DSL. Various frameworks provide different flavors of DSLs. You may write them in Groovy, Java, Kotlin, JSON, YAML. This is actually secondary. Important thing here is that this is the single place in which we define how our microservices communicate. Also, we'd like to draw your attention to the fact that you can test both synchronous and asynchronous communication using contract testing. For simplicity in this presentation, I'm using the REST API example. However, I would like you to remember this is not only one option. Okay, so let's see an example of the request. So this is, an example of the contract, of course. This is first part of the contract in which we define the request. This contract describes this one specific business scenario, which is order creation with payment initialization. So in the request, we have method put, path /payment /any UID, two headers, accept and content type, application JSON, and in body we have 4 fields, account ID, due date, payment type, and quota with some specific values. And the second part of this contract defines what response should be generated for such a request. So status is 200, headers content type with application JSON, and in the body we have 2 fields, payment external ID and status with value finished. And as I said, this is the contract in one specific business scenario, which is order creation with payment initialization. Usually we write more contracts for another scenarios. For example, negative ones. Another example, this is very similar request, however I removed the quota field from the body. For such a request, we expect a response with status 400, content type header, application JSON value, and in the body there should be 1 field with value missing mandatory field quota. So what you can already see is that the contract is actually an example of the communication between two services, but in some specific business scenario. For example, in this positive or negative scenario of creating the payment. It is important to note, because this is in contrast to another well-known solution, which is schema. So in schema, we define field by field what is the name, type, what values it takes. So we kind of hard code the request and response. While in the contract, the schema, it doesn't provide any information what set of the fields is valid in specific business scenario, what contract actually does. Okay, and speaking about the terms related to contract testing, I must explain what producers and consumers are. So, producer, or sometimes we call it provider, is a service which uses the API, which exposes the API, or the service which publishes the messages. While the consumer is a service which consumes or uses the API exposed by the producer, or the service which consumes messages published by producer, in case of asynchronous communication. And in our example, order service is of course the consumer, because it uses the REST API exposed by the payment service, which is the producer. However, if you would reverse these dependencies, and order service would, let's say, publish the event order was created, which is consumed by payment service, then the order service would be a producer, while payment service would be a consumer. I hope this is intuitive enough, and from now on, I will use these two terms. Okay, now it is a very important moment of this presentation, because I will explain how contract testing ensures the communication correctness. So, if we take the producer and consumer, and we test them in isolation, however, based on one single common contract, we may be sure that the services communicate correctly. So, let's see how it works. On the consumer side, or the service, we are still using API stub, and we and we execute our test against this stub. However, now this API stub is based on the contract, and on the producer side, we are just simulating the client and calling the API and checking whether it works correctly. But also, those tests are based on ideally the same contract. How does it help? So for that, I will return back to the issues that I defined against the integration test and end-to-end tests. So, the first one was that using only integration test, there actually there must be like two sets of tests without any synchronization. So, I think that you already feel that this synchronization is ensured by the contract. So, we have the contract between these two entities. So, let's see how it works. So, usually all the, maybe not all, but usually the frameworks for contract testing, they generate the tests for the producer side from the contract. So we don't need to implement them. We just define the contract, and they are generated, the tests are generated from it, and they ensure that our producer API works according to contract. On the other side, on the consumer, we still need to implement the test. However, from the contract, there is the stub generated, so we also don't need to provide it. And as you can see, the test on the producer side and the stub on the consumer side are generated from exactly the same contract. So this ensures that if any change, any side of the communication changes the contract, it reflects actually both sides. Let's see an example. Imagine that in the payment service, someone decided to remove the field from the response. If it is done without changing the contract, the test will fail, right? Because they are generated from the contract, and in the contract there is this field, so they fail. So actually, we need to change the contract. However, if we change the contract, the stub for the consumer is also regenerated. If this field is expected in the response by this consumer, the test will fail. So actually, it ensures that we won't introduce any non-backward compatible change to the contract. And the second thing was that it was about the human communication. And actually, I have a good, or for some of you, bad news. We still can, and even should, come out of our nerd basements and communicate with each other. However, having the contract, it really helps us to organize this communication. So, on the integration phase of the systems, of the services, we can actually put all our, or not even should, put all our agreements regarding the contract to the contract document. Then we can push it to the GitHub repository, version it there. So, as I said, it really helps us to organize this communication, and it is written right now. Additionally, such a contract, it becomes a single point of truth about the communication, because as I said, the tests of the producer and consumer, they rely on this contract. And it also very well documents the agreements. So after a couple of weeks, months, we can open the contracts and remind to ourselves how our services communicate with other services maintained by other teams. And the last issue was that using only integration test, the team responsible for maintaining API does not know how this API is used on production. So we had then an example with 3 services, and each service is using the API differently. How would it work with the contract tests? So with contract tests, on each branch of this communication, on each integration, there should be a contract. In the contract, there is information how this specific service is using the REST API exposed by payment service. So in our example, how can we check whether we can remove any field or this payment type field? So actually we can open the contracts, check whether any of those services is using this field. We know that it is not used, so we can safely remove it without any acrobatic solution, without versioning, just remove it. So all the issues that I defined against the integration test are solved by the contract test. Let's see the end-to-end test now. So I explained that end-to-end test guarantee the communication correctness, and I hope you already understand that because of the contract testing also ensures the communication correctness. However, all the issues of end-to-end test are also solved by the contract testing. We can test in isolation. Expensive? Not really. We don't need any infrastructure for that. Slow and flaky? No, there is not a network between the services tested. We test against the stub, like with integration test. So they are not slow, and there is no really a space for flaky tests. So the issues of end-to-end test are also solved by contract testing. However, to keep it balanced, let's see what are the drawbacks of contract testing. Some people say that contract testing and contract itself is actually another stuff to maintain, or other reason for our test to fail, or another obstacle to our way on production. And yes, I partially agree. We need to maintain the contracts. We need to take care of them. However, if we understand the value that contract testing brings, I actually think this is an advantage. So first, this ensures that we will not deploy the non-compatible version of our service to production, so we will not ruin the business. Secondly, I already explained that using the contract testing, some responsibilities are taken off our shoulders. We don't need to implement the test of the producer, and we don't need to provide the stub for the consumer if we expose the REST API. However, to correctly deploy, to correctly use the contract testing in the project or organization, it requires all the teams to follow the rules. What are the rules? So the contracts are the rules, so we need to write them. There shouldn't be any communication between the services without the contract. Imagine this situation from the previous slide where we had 3 services and each service was using our API differently. And now imagine that one of the service, it doesn't have the contract. Without the contract, we don't know how it uses the API, so we don't know whether we can remove this field or not. So all advantages of contract testing are lost. Last but not least, it may require some additional infrastructure or some changes in the CI/CD to be done by DevOps, let's say. For example, using one framework, which is Pact. It's not a must-have, you can do it without it, but it is recommended to use the Pact broker, which simplifies the contract management. Okay, now you may ask a question. So we have producer, consumer, and contract. But who actually owns the contract? Who is responsible for driving it? There are 2 solutions, 2 approaches. Consumer-driven contract testing and producer-driven contract testing. And those approaches are related to the term that you probably know from the strategic domain-driven design, which is upstream service and downstream service. So upstream service is the service which drives the model, while downstream service just conforms to this model. Just take it as it is. And in the consumer-driven contract testing, the consumer is an upstream service, so consumer defines the contract of communication. Consumer says how it wants to use the API, while the producer just conforms to the consumer's expectation, so producer just exposes the API asked by consumer. And in the producer-driven contract testing, the producer is an upstream service which defines the contract of the API, while consumers are just informed about this contract and use it as it is. Now it's a time for demo. Today I will present you a Pact framework, which is one of the well-known frameworks. And just a recap of the demo scenario. So we have the REST API of the payment service. It's HTTP put with specific path, and we have 4 fields in the body. And I will be testing the happy path scenario, so we expect 200 with 2 fields in the body in the response. So give me a second. It's okay? Okay, all right. So I am in an order service, which is our consumer. And during the presentation, I explained that using contract testing, we don't need to actually prepare the stub. So while testing the consumer, the stub is generated from the contract. But where is the contract here? So using pact, we may use the DSL to define our expectations regarding the communication, it's not contract itself, in the test of the consumer. So I implemented the test, which is the positive scenario, should create order and execute online payment. In this test, I'm using the pact builder, which is this DSL I explained, to define our expectation about this communication. Remember, it's not the contract itself, it's just a definition of the expectation which will be used to create the contract. So I'm defining that this service is order service, this is the consumer, and it has a pact with payment service. Pact is used in the pact framework instead of the contract, so if I'm talking pact, it's contract. And those services communicate on port 8088. And upon receiving a request to execute online payment with attributes, so method is put, path should be /payment/any_UID, and in the headers we have accept and content type with application JSON value, and with body account ID, which is any UID, payment type, which is specific string transfer online, because in this scenario I'm testing only the transfer online payment, quota, which is any decimal, and due date, which is date type. So here I defined the request using with attributes and with body. And for such a request, we expect following response to be returned. Status should be 200, content type header application JSON, and in the body there should be 2 fields, payment external ID and status finished. So here I defined the expectations regarding the contract. Now there is some boilerplate using pact. By the way, I'm using Spock because I like it. Of course, you can also use it in JUnit, but this DSL looks differently. So in this boilerplate, I wrap the execution of the test logic, which is in this line, in the run test method. So in the assertion part, I'm just checking that the payment was processed, which is just a boolean which should be true. And I want to show you that I'm not cheating here, and under the hood, there is a real call to the payment service, which is on localhost 8088 and /payment. So returning back to the test, in the then section, there should be also some boilerplate. So I'm just checking that the result of this pact verification is okay. So now I can run the build of this application, and should be green, I hope. Yes, build is successful. So what happened now? We check whether the order consumer conforms the contract. So we check by whether the logic works correctly, and simulated the API of the payment service using the stub, which were under the hood generated from our expectation. Now we need to test the payment service. And I said there should be the contract generated. And yes, using pact framework, in the build pact directory, there is a JSON generated, which is our contract. So in the test, we had the expectations about the communication, and the contract was generated under the hood in the JSON format using this framework. So now we need to test the payment, the producer side. So how can we do it? We need to somehow provide this contract to this application. So there are a couple of options. We can just put this contract on the class path. However, recommended solution is using the pact broker. And the pact broker is kind of repository for the contracts in pact framework. So how can we do it? There is a special task called pact publish. We can execute it, and the Gradle will just put the contracts to this repository. What we can see here. that the consumer is order service, provider is payment service, and they have the contract. Last verification is empty because we haven't verified the producer yet. And here also we can check this contract. So we see the interactions, our request and response. So now it's time to test the payment service. Okay, so during the presentation I said that on the producer side we don't need to write any test. We don't need to implement it. However, you see the test. Yes, actually we don't need to implement the test scenarios. However, we need to instruct to configure the framework to run the test from the Prague broker. So Spring Boot test annotation to run the Spring Boot machinery under the hood. We configured that this service is a provider called payment service, and also Prague broker annotation, which explains to the framework that, okay, you should take the contracts from the Prague broker. And some boilerplate to actually run the test. So as you can see, we don't need to implement the specific test scenarios. And now I may run the build of this application, and let's see what happens. Okay, it's failure. Let's see. Packed between order service, payment service, a request to execute online payment, it failed. Yes, expected status was should be 200, but was 404. The failure. Okay, so if we go to the packed broker, interesting thing here is that we see that less than a minute ago it is red. So the verification of this API failed. This is by this is of course expected because the API was not implemented. I will cheat here a little bit, and I will add this API to this service, and also I will change the version just to see it correctly in the pack broker. And so I fixed the issue. I exposed the correct REST API, and I'm running the build again. Now it's successful. So now we are sure that two services, they cooperate correctly. So let's go to packed. It was red. After refreshing, it is green. Nice, right? We can also check here in this grid that version 1.0.0 was incompatible. It was red. However, the 1.01 it's okay. It's green. But okay, you probably won't want to check every time in the pack broker when you want to deploy the service to production whether it's green or red, right? So the pack broker also exposed a nice feature which is called Can I Deploy? That allows us to automatically check whether we can deploy the specific version of the service to production, and it connects to the pack broker and checks whether the interactions were checked correctly, whether the services can be deployed safely. So for that, I'm returning back to the order service, and yes, there is the Can I Deploy task that we can execute. Can I deploy? Okay. And we need to provide what kind of participant, what kind of service we want to check. So here I am in order service, and I want to check whether I can deploy this version with payment service, right? So the participant, it's not a typo, it's participant from pact, should be payment service, because I'm checking with payment service, and I want to check the latest, or maybe the specific value. Participant version. Let's check for 1.0.0. I hope I did it correctly. Oh, something is wrong. Participant. Ah, yes, thanks. Computer says no, and we have build failed because 1.0.0 is not compatible. However, if we check it for latest, which is 1.01, this should be green, build successful, and computer says yes. So as you can see, you can use this Can I Deploy task, use this tool, and in your CI/CD pipeline, and check whether the specific version of your service may be deployed to production. Okay, need to come back to the presentation. So, takeaways. So contract testing is an alternative approach to testing the communication when you want to ensure the communication correctness between the services and also the backward compatibility. It uses the contract, which is kind of synchronization mechanism between those two entities, consumer and producer, and it also nicely documents the communication. It also provides insights how the API or messages, remember it's not only about the synchronous API, but also you can use it for testing the asynchronous communication. So it provides the insights how it's used by consumers, and the well-known frameworks. Today I showed you Pact, and there is also the framework which is Spring Cloud Contract. It is a little bit closer to Spring and JVM, but still with Spring Cloud Contract you may also test the applications which were not written in Java or JVM language or Spring. Okay, I'm finishing. So before we go to the questions, I would like to kindly ask you to rate my presentation, the inventory app. As you probably know, there is the Jugmeister competition going on JDD. But it's not only about the competition. Your feedback will help me to create better presentations in the future. So please, please, please do it. And thank you very much for your time with me. On this slide, you have a couple of important links. If you want to see more examples about the contract testing, this is the link to my GitHub repository. There are the examples of both synchronous and asynchronous communication implemented with Kafka, and using both Spring Cloud Contract and Pact framework. You may find me on LinkedIn and Twitter, and if you want to read more about the contract testing, this link, it goes to the Software Mill blog, and there is the series of my articles about contract testing. So thank you.